Hello, everyone. Welcome to the first community meeting of the last month of the year for wasmCloud Wednesday, December 6th. We have a pretty quick demo for the beginning of the call today, and then we're going to be talking about a retrospective on the roadmap that we put out earlier this year in August and how we've essentially done quarter three, quarter four. I know we're not totally done with quarter four yet, but we've essentially got enough information to do this retrospective and see how we did on our goals. And then looking forward from there at 1.0. And then I wanted to queue up a little discussion to talk about the control interface stabilization RFC. We've got a few RFCs that are going into wasmCloud 1.0 that are going to be important for stabilization, for design decisions. And the control interface one is one of the bigger pieces that's closest to being ready for work. We've kind of put together a couple of proposals, and I want to run through those on the community call, give everybody a chance to weigh in, but obviously you can always weigh in on Slack. Okay, let's start with a little fun demo, which I think it's been a couple of us, I can't remember if it's me and Bailey or me and Caroline, we've been throwing around this notion of like what we're calling like the bring your own component feature for wasmCloud. And this isn't really even a feature that we inherently or explicitly need to implement. It's really just that when you run WebAssembly in wasmCloud and you're using WebAssembly components, there's really only this standard set of imports and exports that you're going to be using for like the vast majority of your application components. And that's going to include things like the WASI HTTP proxy world for doing your HTTP requests and things, and the WASI CLI world for doing your file systems, your standard ins, your standard outs, things like that. And then there's also support in wasmCloud because we need to support custom contracts, essentially having your own operations like the wasmCloud guest call world, which is really similar to our other or our stable ABI wasm-bus protocol. So when you go and you look at our documentation, we're going to have tailored guides for some of our languages that we have the most experience with and have the most mature tool chains. But WebAssembly is going to inherently support more than just like Rust and Go and JavaScript, the big languages that we're going to try to add the extra syntactic sugar on top of. And so we have this notion of bringing your own component to wasmCloud. And that's all just the idea that if you have a WebAssembly component that has a certain set of WebAssembly imports and exports, then no matter what the source language is, it will be compatible with wasmCloud and everything that we're doing with it. This is wasmCloud specific on this meeting, but this actually extends to each WebAssembly runtime that implements the component model and uses the standard WASI interfaces to do what they do. So I want to show you this example, and I'm using the componentized.js project to actually make this work. This is a project in the Bytecode Alliance, if somebody wouldn't mind finding that link and just throwing it in the chat. But I essentially just followed their example in their README, and then adapted, and I don't mean adapt in like a WASM adapt sense. I edited the WIT file to meet something minimal that I can use to execute it in a wasmCloud context. So this is kind of part one of the bring your own component demo. And any language that could support using like embedding this component metadata could do this too, but I'm going to do it in JavaScript because we don't have any documentation or examples in JavaScript, and that's kind of a fun thing to see work. So this is the first step. Now, for whenever we get to show this off again, the bring your own component, I'd actually love to do this using like the WASI HTTP world. So I could link it to an HTTP server provider and throw an HTTP request at it. But I just wanted to work with the minimal example here. So this is my WIT file. I'm calling this package wasmCloud bus, but for this reactor component, you can name it whatever you'd like. I have one simple interface, which is just this function called call. And this is actually this guest call interface is exactly what wasmCloud is expecting for a generic handler where we call an operation on a WebAssembly component. And then I'm exporting that function call here and export guest. Now I also have this JavaScript file, which is really small. I could probably zoom in a little more, actually. It's really small. I'm just exporting this guest constant with this one function called call, and it has an operation here. Actually, this would be a really cool thing to modify. Let me see if, let me do some runtime stuff. So we'll say hello from JavaScript, and then we'll just give back the operation name too. So we'll be able to actually supply this at runtime with wash call, and we'll get to change it, which will be fun. Now, I've built this example using the componentized.js, tool chain, which is essentially this JavaScript that you can run using Node. So we read in our JavaScript file, we read in our wit, and then we componentize it and then write out that component. So if I were to do this just with Node, we can run node componentized.mjs. And then the output of that is actually a component, this hello component.wasm. We can use wasm tools to check out this component. And you can see, because I have, actually don't know if this was super obvious, but in here I've enabled standard out as a part of the componentized process. And so doing that, I import all of these WASI functions for WASI CLI for getting like terminal input. Really, the only thing that I'm really going to care about here is outputting to standard out. And then I'm exporting my one function, wasmCloud bus guest. So I've built a component. Now we know that the next step for running this in wasmCloud is signing the module. This is something that we'll probably be talking about a lot over the coming weeks. But what we essentially need to do is say, hey, I'm the person who's signing this, and give this module some identity. And so to do that, I've gone ahead and done a little pre-work for the demo and brought over this wasmCloud.toml. And I can actually remove that using an HTTP server. And I've added in the features that we talked about in the, I think it was last week's community call. Yeah. I have supplied kind of a custom build command here so we can run that node process to build it. I expect for the build artifact to be in hello.component.wasm. And then the signed one, I'll output to hello _s to denote that it's signed. Now you'll notice one thing that may not be technically right about this wasmCloud.toml, which is, of course, that this is not going to be a Rust actor. Right now, this is a required field, but I think we're going to actually look at making this language something that you can put in your own. And if it's not Rust or TinyGo like what we expect, then we'll ask for you to supply a custom build command. This is how this is how bring your own component is going to work. Because you'll be able to drop into an existing project, add your wasmCloud.toml, and then run wash build in order to build the component using the native toolchain for the language, and then sign it at the end of the day. So we get this hello _s component.wasm. We've built this. We can do the whole wasm tools command on this as well. It's still the same world, nothing changed. And we can also inspect this component to see that it doesn't actually have any capabilities. It's not going to be reaching out to the file system, things like that. Okay, so we have our component. And speaking of pre-work for the demo, I've gone ahead and launched Nats in the background. And I'm running wasmCloud from main, and I'll talk about why in a second. But if I run watch get inventory, just want to make sure I didn't leave anything. Aha, I did leave some things. So let me go ahead and stop the actor from before, and we can stop the echo actor that I was using previously. Get inventory. What we can do now that we built this component is we can just tell wasmCloud to start the component from a file. We're going to I'm just pointing it essentially directly at this directory, really easy. If we were using something like wash dev to do the iteration loop, this would be a little bit quicker because you can just supply the file and then go from there. But this is just going to tell wasmCloud to go start this component. we check back in on the inventory. We'll see here in a second. I'm actually running in debug mode, which actually takes quite a minute to run the component from a file. But of course, that won't apply when we're running in release mode. So when we go from the component, as you saw in JavaScript, our operation, we're just going to throw into the string and say hello from JavaScript. Let me make sure it's running. There it is. I can actually use wash call here, and don't be too worried about the cluster seed being out. I generated it before this call, so it's a safe to discard secret. We are going to call this actor with the operation community.call and get back our nice string hello from JavaScript community.call. We can edit this to community.demo, for example, to see that we're actually executing this function inside of the JavaScript component. But this is really sweet because this component is written in JavaScript. This is really a lower level example of what we want it to look like when people are writing components. Realistically, the idea here is that this component, this hello component, would have already existed and is already using the standard WASI CLI interface. And you simply add wasmCloud.toml and a wash build command in order to build it and then be able to run it in wasmCloud. So this is like the simplest beginning iteration of what this will look like. And everything gets a little bit easier with more examples, more things that we can pull from the community. So we're going to be looking to find some more of those, contribute more of those, all those fun things with the goal of just rapidly expanding the language support in wasmCloud. So that was a JavaScript component running and executing in wasmCloud. Does anybody have any questions?
That was great, Brooks. Pretty cool.
I've been wanting to mess with JavaScript components for a while, so I was glad to finally kind of have the kick in the butt to go make it work and see what it looks like. If we can form some of this up, actually, I would love to get it formed up using WASI CLI and WASI HTTP as the only, essentially interfaces that we're pulling in. Love to throw this into the wasmCloud monorepo, the examples directory. We'll probably just put a nice little guardrail up there at the top, like this is experimental, try this at your own risk and fun, but we'll get there. Alrighty. Well, nice. Does that work for mine? Wait, what did you do? You did this? Yeah. Oh, my video totally froze for me. I don't know if it's working for you. Okay. Well, with that, when we move on, did that work?
I think you're broken.
I think you just locked everything up. I don't know. There we go.
Okay, there we go.
Good. Two balloons. You got a party.
Okay, this one works. Just no double thumbs up on the call. Got it. Well, let's go ahead and move forward with the rest of the. Anybody have any questions? Sorry, I meant to pause there for a second. Alrighty. Then let's go ahead and move on to the next part of the call, which is really just around looking back at our Q3, Q4 roadmap and doing a little retrospective. How do we do? We actually published a blog on this morning, just about an hour or two ago. So if you want to get the nice voice of a blog language around our roadmap, you all are welcome to go check this out. This is something that we're kind of sharing out broadly to look back at our goals. But I'm just going to run this through our regular roadmap page just to give you the commentary from the maintainer perspective. So this is the roadmap that we published out in August. So this was meant to encapsulate essentially the work from August out through the end of the year. And really the whole theme of this, the theme of this entire roadmap is supporting the common standard and giving ourselves a base to really launch off of. If we look at our goals, you can see that our number one goal here, these were kind of loosely ordered, not in terms of importance, just somewhat in terms of importance, but more around like, what are we really focusing on? The first one is leveraging as many WebAssembly standards as possible. Using WASI, using WebAssembly, implementing WebAssembly components, using wasmCloud interfaces, etc. So this first goal is really all around taking our existing protocols and methods like WASM-bus RPC, compiling to WASM32 unknown modules, WASI Preview 1 style, and really trying to leverage the WASM standards that were under rapid development. And put more details in the blog here, but I would argue that we've been massively successful on this goal. Super excited to see the type of component support that we have in wasmCloud now, which, like as you saw a little bit earlier, we've never worked on a JavaScript guest SDK in wasmCloud. And yet I was just able to throw some string back from JavaScript into a wasmCloud ecosystem. Those kinds of things are exactly what we wanted to get out of that, and supporting more and more of the WASI interfaces is key to that. Us actually having support for the WASI CLI world, WASI HTTP world, things like that. Other than that, looking forward at wasmCloud, these interfaces are continually evolving. This is an area where I feel like on the wasmCloud side, we have a great bit of expertise operating these interfaces in a cloud context, things like key value, messaging, file systems, blob stores, things like that. And we have support for things like the wasmCloud, the blob store interface today. But those are continually evolving. And we are leveraging as many WebAssembly standards as we possibly can at this point. So very happy with this first point. Anybody is welcome, by the way, if folks want to chime in and add on more information or refute one of the claims. That is totally fine. Number two, we really wanted to provide a seamless developer experience for building, testing, and deploying WebAssembly components. This is a really difficult one to call done, to say that, yep, we have provided a seamless experience and we are good with it and happy. We've made leaps and bounds of progress in making our developer experience better, running the wasmCloud runtime in Rust. And so, working on running the Rust runtime using washup makes things a lot quicker. The ability to build and test the runtime using components and modules is even better. And some of the developer experience that's recently gone into Wash around like custom components, human-friendly names, the ability to use Watum to deploy an entire application. We have provided a much better developer experience. I can't at this point say that we are completely seamless. There's always work to do in this space, but this is something that's going to go into our 1.0 roadmap. This developer experience is something that we're constantly working on and improving, which is good. Moving on from there, I think that we kind of brought these together, these next two goals, the best way to build vendorless components for WASM applications and bringing joy to distributed computing, where distributed computing goes into our developer experience. I really think that wasmCloud right now is the best way to build vendorless WebAssembly applications. The capability-driven model that we allow you to connect to capabilities at runtime, even now using WASI interfaces, those are essentially transformed by the host, and you can use capabilities or loosely coupled capabilities. The ability to not tightly couple your application to the underlying platform or a specific vendor is something that wasmCloud has always done very well, and really happy with the experience there. Last but certainly not least, talking about leveraging cloud native standards where possible. This is really one just to keep us on track, and something that we, other than extending and working with the OAM spec in WATM just to make it better and easier to edit. This is something that we have already been implementing for a long time using OCI and cloud events and other cloud native standards. Most notably, coming in looking forward will be instrumentation using OTel metrics, shipping off OTel logs over the exporter in addition to all the traces that we export. I think that the three pillar of observability there with the cloud native standards is the important thing for allowing wasmCloud to essentially slot into a cloud deployment today. So looking back, there were a lot of things that we wanted to work on when it comes to our current or now next and later roadmap at the time of release when we put out this roadmap. And if you can look at all of these things in the now column, these are all things that we accomplish very well. So WashBuild produces WebAssembly components. We have our WIT provider SDK that we're using to now write all of our new providers, and Victor has been working on transferring all of our old providers over. Victor and Taylor, and I know Connor has been doing a little bit there as well. The Rust host has support for WASI command and reactor components, and there's a new washboard that works with it. And we're supporting as many standardized WASI worlds as we can. Looking over at the next column, these are the things that we are essentially saying, hey, we're going to push these to after our Q3, Q4 roadmap and see where we are. These are the things that we are essentially looking at now for supporting 1.0. Things like having a really seamless developer experience around wash dev and WATM so that you can do a declarative iteration loop. Improving our link definitions and strategies on versioning. We can actually see a couple of RFCs popping up here now in the wasmCloud repo. And then just transitioning all of our examples to be all components, all by default. And you can see on here that Componentize and JCO are making this list explicitly because JavaScript is such an important language to have as a sample. So all these things in the next column are going to be things that we're examining as we're looking at the 1.0 roadmap. I know we've all kind of looked at that last week on the GitHub project board, but those are either making it into RFCs on the roadmap, or they're going to be pushed into the next, the 1.0 next, things that don't need to make it into a 1.0. All right. That is a lot of talking, but I wanted to call attention to the blog that we have, and I wanted to point people towards my thoughts on the issue or on the whole roadmap retrospective. I'm looking at chat. I just saw an entire WIT file get pasted in, so I'm assuming y'all are talking about something different. Alrighty. Do folks have any questions or comments on Q3, Q4 roadmap? Some of the things that we have been working on. Anybody is welcome to chime in here. Alrighty, then I think we can go ahead, quick move through the agenda items. We can go ahead and move on to the last example in the last action item in the community call, which is the wasmCloud control interface stabilization RFC. So as we look towards 1.0, this is a really important thing to look at all of our protocols, essentially the interaction points between the user or the developer and wasmCloud. So because we're just going to be publishing the wasmCloud binary, Some of the things that need the most scrutiny are the topics, payloads, and methodology behind our anything that we communicate with over NATs. These are things we're gonna want to call stable, or at least be able to support the same version in a backwards compatible way as we do 1.0. So looking at the I wrote up this RFC, but it comes after some good chats with the wasmCloud maintainer. So I'm not going to take I'm not taking all of the credit for the ideas put forth here. But some of the main things that we want to look at are standardizing the topic format. If you haven't really worked with NATS topics or just subject-based messaging at all, essentially all of our clients like Wadum and Wash will communicate with wasmCloud over these sets of version topics instead of hitting like a specific, HTTP endpoint. And what we're proposing in this RFC is that all of our control interface topics follow this convention, which is wasmbus, and dot is a common separator, wasmbus.ctl version lattice prefix verb noun, and then optionally host ID for any of those operations that require a host. The topic format needs to be versioned here. You can see this in the topic. This is new. And the reason is we want to support we want to be able to protect from future changes that are incompatible over the wire. So essentially hitting 1.0, the entire version, it's always going to be V1 until, maybe sometime in the future, unsure, there's some breaking change with the control interface protocol, and then we can move on to V2. This is the same pattern as like, in Kubernetes, the API version for a lot of the resources is V1 beta 1. You can see this in HTTP APIs as well. And it's really just a mechanism of protecting ourselves from the future. Yeah, Connor.
Just a little, I think there's a typo there. I think we agreed on .noun .verb.
Yeah.
Hold on. Wait. Hold on.
I mean, sorry, I accidentally clicked the raised hand. I didn't have anything to say.
Yep. Hello, everyone. Welcome back from this definitely not cut. Today, I want to talk about the control interface RFC. No, just kidding. So yes, noun.verb is the one, and I'll talk about why, because it actually originally was proposed as verb.noun. So the last part of this is just ensuring that we have the set of operations that we like, because introducing new functionality, though it's not breaking, can be difficult to, point at a version or point at a wasmCloud host and say, oh, is this a new enough version that supports this operation, or is this not? And so you can see a couple essentially all the examples of the current operations that we have on the control interface and what I'm proposing that the new topic be here. Yeah, Yoshin, go ahead.
So we're currently doing a POC with wasmCloud and bring it to our IoT edge devices. And we're multi-tenant, right? So we have account perimeters in NATs around specific locations. And is there any best practice or documentation about how to make the wasmBus control interface multi-tenancy capable?
Yeah, we've actually, let me pull up the Wadum documentation. We have some of this in the, where is it? There it is. In talking about multi-tenant lattice management. And there are kind of two aspects here, but one security boundary that we really recommend when it comes to multi-tenant NATS environments is, using separate NATS accounts or separate user credentials. And then you can actually, the wasmCloud host itself doesn't even need to know that you're doing it, but you can add an account prefix on the wasmBus control interface topics, for example, and then publish everything to your axxx.wasmbus.ctl, and then that user imports it as that user imports it as wasmbus.ctl.
Yeah. Okay. So import export. That's the general way we're doing that as well.
Yeah, that's a great way to do it. It's worth mentioning that all of the each wasmCloud host is also specifically tied to a particular Lattice prefix. So if you have a multi-tenant model where you're not too worried about different wasmCloud workloads like snooping on the other, you're not worried about them seeing each other. You just want to keep them logically separate. You can run wasmCloud hosts. There's a command line flag at runtime called Lattice prefix, and you can. It's a little more than a namespace, but you can think of it very similar to a namespace, and that can exist outside of a specific NATS account hierarchy.
Okay, thanks.
Yeah, great question. So moving just a little bit forward on this one, for example, we have some operations here where we put the host ID in the middle of the topic, some operations where we have verb then noun, and then some where we have noun then verb. And in Wash, we actually decided to go with the verb and then noun approach for a nice, easy to use CLI, things like wash get hosts, wash get links, things like that. It flows a little bit more with the English language. But with topics, I originally proposed that, but then changed to, wait, why? I changed this back accidentally yesterday then. I'm proposing that we're going noun and then verb, and here's why. So a couple examples here for the launch provider topic. Used to be wasmBusETL, Lattice, command, host ID, launch. And so I actually need to move that one as well. Darn, some of these examples I still need to update. So let me look at these, for example, auctioning provider. I'm proposing that we go to provider.auction, auction.actor, actor.auction. Same thing with scaling an actor, for example. We'll do actor.scale or actor.update. And the reason actually came from Connor here, who left the comment that if we do noun and then verb, then we could subscribe on the control interface for all of the operations that affect actors. For example, we could subscribe with just a simple caret wildcard. We could subscribe to all the things that affect providers, all the things that affects hosts or link definitions. It really just makes it nicer to be able to subscribe on the control interface and pull off very specific or pull off specific ideas. So that's why we're proposing noun and then verb. And then other than that, the only other things that are worth chiming in on this RFC for, or some of the other things are newly proposed topics, which is updating providers and updating links. We have a method now to hot reload or hot update an actor in place. So essentially we download the new actor bytes from whatever registry, and then we start the new version of the actor, and then we stop the old version. So it's a zero downtime way of updating the actor in place to a newer version. And I think that would be really nice to have for capability providers as well. And links. Links is a little bit harder because it takes place over the entire lattice. So it's going to have to work a little bit with Jetstream and each host implementing that. But it's not any more more difficult than deleting and putting a link. The main thing that I would love to just have here is a way to upgrade each component in the wasmCloud system in a zero downtime way. And then Wadum can do much cooler things with rolling upgrades and zero downtime upgrades, things like that. So I think I put this in the chat. Let me just double check. I'll throw it out there again. Everybody is welcome to kind of read through and digest this on your own. There's some great discussion here around the topics. But this is going to get turned into an ADR shortly after we finish discussion. We'll give it another week or two. and then try to break down this RFC into a couple of concrete pieces of work. We can do the effort to rename the control interface topics before we implement the new operations, or vice versa. So that's this is one of the slightly meatier RFCs that we've got out, and so I wanted to leave plenty of time for questions. So that being said, other questions? All right, folks. Quiet call. I guess it's getting to the holiday season. Everybody starts calming down and all of that. We'll still be rolling our community calls out through the rest of the year, and then through next year and every year after that, every Wednesday. But I think that's the end of the agenda for now. Does anybody have any general questions? This can be all around the wasmCloud ecosystem, WebAssembly standards, all those things. It's totally free time. Yeah, feel free to jump in. All right, folks. Well, then I think we can go ahead and call it for today. Thank you so much for coming in the middle of your day to the community meeting. We'll go ahead and stop the recording, and we'll see you next week.